We're hoping to scale that back down to a 30 number. So it is different countries due to data restrictions, right? You can't move it out of country. So we do require that. So it will be in multiple countries. You know, we're thinking the number is going to be 30 to 40 at the end. Wow. But again, when it's our data center, that's a huge cost.
Yep.
It's your data center. I'm only paying for what I use. Makes it much easier. And now putting Oracle in that data center, I don't need an on-prem as much as I used to. We can operate in the cloud with a couple of trusted partners.
Yeah, fantastic.
Yeah, well, it looks like you and I have some work to do.
Excellent. I guess we've got some rollout plans. We'll definitely get that prioritized list and get going on it.
Yeah, definitely. Looking forward to it.
Okay, we're looking forward to it too.
Awesome.
Announcement.
Cool. Thank you so much.
Thank you, Matt. This is great. Thank you so much.
That'd be great.
Good to hear. Thank you both very much for being here. Okay, once again, the lower line is in alphabetical order. You know, again, it used to be Oracle Open World, now it's Oracle Cloud World. I think Safra probably will not agree that we should call it the Open Multi-Cloud World. Or maybe that's okay, we'll find out. But I do think this is a very different situation than we had only a few years ago, where I think you'll see more and more the ability for customers to use different services from different clouds and gracefully mix them in a single application. And as you heard from Andy, you know, large companies operate in a lot of countries. Sometimes there are data sovereignty rules that have to be obeyed. So this multi-cloud world is going to involve lots and lots of new data centers scattered, you know, throughout the globe. It really is very exciting. As you know, Oracle has now reached the point where we have connected our cloud to AWS. We put OCI data centers in AWS. We put OCI data centers in Google. We put OCI data centers in Microsoft. We've interconnected to the 3 other major infrastructure providers in North America, but of course they're not North American companies. These are global infrastructure providers, the largest global infrastructure providers. So again, giving customers choice has always seemed like a good idea. Customers seem to prefer having choices, and it's always, and Oracle historically has always provided choices for customers. Okay, so the idea that we've connected to all of these public infrastructure clouds, oh, that's interesting to read. Okay. We've talked about AWS, Azure, Google, and Oracle. Maybe we didn't mention, we also connect to Fujitsu in Japan. We're building data centers inside of Fujitsu. We're building data centers inside of NTT. And we've already built 4 data centers at NRI. That's called Nomura Research. And they are an infrastructure provider using the Oracle Cloud. And maybe the most interesting application they run in the Oracle Cloud in Japan is they run the Tokyo Stock Exchange. As far as I know, it's the only stock exchange that runs their entire business in the cloud. So it's really very interesting as we embed our data centers, the OCI data center and the Oracle database and a bunch of other Oracle services in these different clouds where Fujitsu now can service their customers using the Oracle database and the OCI cloud. So will NTT, so will NRI, so will a number of other Japanese companies. And it's not a one-way street. It's not that it's just a matter of you're in AWS, you can use the Oracle database. In our connection with Google, if you're a Google Cloud customer, you can use the Oracle database. If you're an Oracle Cloud customer, you can use a Google Gemini from the Oracle Cloud. So the interesting thing about this multi-cloud world is whichever cloud is, if you will, your primary cloud, you can reach out to other clouds, infrastructure clouds, and very soon application clouds, and mix and match the applications and the services you want. Another interesting thing about OCI is we have private cloud offerings in addition to our public. I've been talking about public clouds now, up until now. AWS, Google, Microsoft, and Oracle all have public clouds. But we're different in one important way, and that is we also have private clouds, private infrastructure clouds. In fact, we have three flavors of that. Enterprise, DRC, that's dedicated region clouded customer. In other words, let's say you're a big customer, like a Vodafone, and you would like to use the Oracle Cloud, but you don't want any other tenants. You don't want any other users in your version of the Oracle Cloud. Yeah, I like the Oracle Cloud. Build me 6 of them. Build me 6 data centers, and Vodafone will be the only ones in that cloud. We don't want anyone coming into our cloud with a credit card. We don't want anyone coming into our cloud that we don't know. We want a private cloud. Our private cloud is absolutely identical to our public clouds. Every service, every feature is in our private clouds that are in our public clouds. So it's not an abbreviated cloud in any way. They're absolutely identical. And we have dedicated cloud regions. We have an alloy cloud. NRI is an example. They have four clouds, 4 private clouds, and they provide services, as I mentioned, to the Tokyo Stock Exchange. Well, they sell those services. They charge for those services. So Ally is a way that Oracle gets cloud business partners that will resell the Oracle Cloud services to their dedicated customers. NRI is a perfect example of an Alloy Cloud customer. And then nation states, countries that are very concerned that their data remains sovereign. They want their data in their country. Certainly all the government data, maybe all the healthcare data, they want kept in their country. And so we can build those countries sovereign clouds. Again, it's a private cloud, but the sovereign cloud would be located, in this case, an example would be Serbia, but Thailand. There are many examples. We built these sovereign clouds where they can keep all their government applications in a dedicated private cloud where it's only government applications. They keep all their healthcare data in their country. We can do all of that. We're building not only public clouds and expanding our public cloud, but we're building dedicated private clouds for some of our most important customers. And it gives you more security because it's a private data center. There's nobody there. It's a private network. It's behind your firewall. And there are no tenants in that cloud that you don't approve. So it's, again, one of the things that Oracle offers that the other cloud companies do not. And we're seeing pretty good uptake on our private cloud business. Oracle at this stage has 162 public and private cloud data centers around the world. Actually more than that now, because we've actually started on our first AWS cloud data center. But we have 162 public and private cloud data centers either already completed and running or under construction, and many more on top of that planned. So we expect to have a very large number of cloud data centers, measuring in the hundreds, probably measuring over 1,000 in the not too distant future, because a lot of our customers are telling us, yes, they want to move to the cloud, but they don't want to move to the public cloud just yet. It might be a regulated bank and they have regulatory issues. Might be a country and they have sovereign data issues. Anyway, there are lots of issues. Our job is to provide customers with choices. We have a lot of public cloud regions all over the world, but we also can offer you a dedicated cloud for your company or for your country. The These clouds are all identical except for size. We build the largest data centers in the world. The really huge data centers that we build are typically for our AI training customers like NVIDIA, OpenAI's ChatGPT, and xAI's Grok, which are currently being trained in large Oracle cloud data centers. But we actually, well, 800 megawatts is gigantic, and we actually have data centers in planning that are over a gigawatt. Our data centers also currently can go down to 144 kilowatts. So when we can offer you a private cloud very, very economically, it will fit in your data center. It is not, and the costs are identical. The cost for running the Oracle database in a private cloud is identical to the cost running the Oracle database in a public cloud. You can run Fusion applications in a private cloud, HCM, CX. You can keep your Cerner entirely in your sovereign cloud, so all your health data is in your country. There are lots of uses of these private clouds, and we see an increasing popularity amongst our industrial customer companies from different countries, from telecommunications companies, from regulated industries like financial services, all of them very interested in private cloud. Okay, now I'm going to change subjects, and I'm going to talk about cloud security. More specifically, I'm going to talk about how we as an industry, can use AI. We, Oracle, the company, can use AI to dramatically improve cloud security. I mean, improve it by a factor of 10 or a factor of 100. Do things that everyone wants us to do, like get rid of passwords. Passwords are a terrible idea. Passwords that are 17 characters long, including special characters that no one can ever remember and has to write down, are unbelievably easy to steal. The cyber wars are getting worse, not better. We've got to find better ways to authenticate people than asking them to type in a password. Okay, there are 4 pillars. We look at 4 pillars of security at Oracle. One is data security. Make sure under no circumstance can people look at your data, steal your data, or lock you out and away from your own data. I mean, we have to absolutely have absolute data security. And Oracle, everyone knows Oracle's first customer was the Central Intelligence Agency, and they take the data security very seriously over there. And we've taken data security very seriously since we started the company. And I think we're pretty good at keeping your data safe. But I'm going to talk about more things that we are doing to keep your data safe. The next is application security. Oracle writes a lot of applications. We wrote the NetSuite. We wrote Oracle ERP, Oracle HCM, Oracle Fusion CX. All of those applications. How do we write those applications in a way that they're more secure than they are now? Do we just do a better job of training our programmers? Do we make sure we audit all the code to make sure there are no security vulnerabilities? What do we do? Next thing is user identity. I said passwords, got to get rid of them. And then finally, network security. How do we make sure that a bunch of credit card data isn't flowing from one of our databases onto the internet? Data is not being exfiltrated. How do we continuously monitor our network to make sure no data is flowing from point A to point B, where point A and point B aren't pre-authorized by your security what we summarize, what we need to do is a set of cyber robots to face these attacks. Data security. How do we keep your data safe? Very simply, using autonomous systems. Autonomous, fully automated, fully self-driving systems. Just like self-driving cars. Self-driving cars are much safer than human driving cars. The robot isn't going to go 130 miles an hour on the freeway. The robot is not going to have a few drinks after dinner and get in the car. We can save lots of lives with autonomous driving cars. We can do a better job of protecting our data if the database system that is managing that data is fully autonomous. And this is something that Oracle has been working on for a very long time, and we think we're quite good at. Almost all cyber attacks begin the same way, with human error. The Oracle Autonomous Database has a robot DBA. The robot DBA automates everything. Human beings don't configure the database. There's a famous story of a large bank running a big application in a cloud, lost all of their credit card data. And it came out that the bank's programmers made a mistake configuring the system, configuring the database, and they left it vulnerable to the public internet. And literally every single credit card user lost their credit card data. That cannot happen with the Oracle Autonomous Database because human beings do not configure the system. Robots configure the system. It is fully self-driving. It configures itself. It decides, it encrypts everything. It backs itself up. If you have to recover from a backup, it does that fully automatically. There are no human beings involved in backup. There's no human beings involved in recovery. A new version of Oracle comes out. The software automatically gets updated. There's a security patch that's available. It automatically patches itself. You need more capacity. Well, because we use cluster, the database runs on clusters, Exadata clusters and Exascale, the next generation of Exadata called Exascale, runs on Exascale clusters. If you need more processors, we just get them from the pool. But it's done automatically. Human beings don't do that. If a bunch of processors go down, the system keeps running. Who keeps it running? It does that automatically. There are no human beings involved. If the data center catches fire and burns to the ground, your application is running in a separate data center without missing a beat. No human beings involved in the recovery whatsoever. No human labor, no human error. But you have to be willing to pay less to use autonomous systems. It's really interesting that it is the most economical way to do things and the safest way to do things. This is so important to Oracle. We have decided that all of our applications have to be moved to the Oracle Autonomous Database because it is so much more secure than a database where you have DBAs configuring the system, DBAs backing up the system, recovering the system. So already a lot of our stuff runs on autonomous. The new Cerner Health stuff called New Millennium, that all runs on the autonomous database. We're building next generation Fusion sales and Fusion marketing. I shouldn't say it's next generation, new products in Fusion sales and Fusion marketing. We're not obsoleting anything from Fusion. But the new updated versions of Fusion sales and marketing are run on the autonomous database. Almost all the industry applications run on the autonomous database. It's more secure, it's much more reliable, it's much less expensive to use. And by 2025, we will have moved all of our applications to the autonomous database. We will be off the older databases. Everything must be autonomous, not to save money, but to keep the data safer. To no human labor, no human error. So that's the first thing. The first thing we do for security, using AI to build autonomous systems and get rid of human errors that allow people to steal your data. Another thing that runs on the autonomous database is the Oracle Cloud. There are lots of things in the Oracle Cloud. We keep track of your configurations, we keep track of user authentications and all of those things. All of the databases that run the Oracle Cloud must be autonomous. We can't have our cloud at risk. It's got to be autonomous. And right now, the Oracle Cloud, almost every database in the Oracle Cloud is autonomous. I think there might be a couple of exceptions, but pretty much all that's been migrated to autonomous. It allows OCI, it makes OCI faster and much more reliable, and requires much less human labor. It allows us, all of our data, the idea is all of our data centers need to be automated. All of our data centers need to be fully automated if we're going to provide you with the economies of a low-cost, high-performance cloud. We have to be able to keep it secure and minimize labor. Okay. Next pillar of security, using AI again. People talk a lot about code generation. Everyone's very excited that ChatGPT can write Java. It can. It can write Python. It can write JavaScript. It can write a whole bunch of things. It's very interesting. Some code generation, you use a large language model to generate a traditional familiar language like Java. But you also can build code generators specifically to generate applications. Not when you use a large language model to generate applications, you translate English into Java. And some people think that might not be the most efficient way to describe programs in the English language. Everyone knows the English language. I should say everyone in this room probably knows the English language. But it might not be the most precise way to describe a computer program. So we can have that debate. Both types of code generation are useful. Where you invent a new language that's designed to be a code generator, and it builds the application, or you use English and you describe it in English and you build the application from English. Well, this is an area where Oracle has built a language called Apex and made, in the last couple of years, since the dawn of, if you will, the AI era, we've made huge changes to Apex. And it can now generate very sophisticated applications. When it generates the application, it's very interesting. And by the way, we're generating the majority of the new applications that we're, quote, writing. We're really not writing, we're generating using Apex. So we are both an infrastructure company and an application company, and more of our applications are generated using Apex. So what are some of the advantages of using Apex? Everyone says, well, we get 10x productivity versus hand programming in Java. Yeah, we do. We get huge productivity gains. More important is our security. When the application generator generates the code, we don't generate security vulnerabilities. We don't generate security vulnerabilities. A computer program is writing the code. It will not make that mistake. It will not generate a vulnerability that you have to fix later on. It will not create something called state in an application. I'm not going to go into it, But there are stateful applications and stateless applications. A stateless application, if your data center burns down, we can immediately fail over to a different data center. They're easy to recover, but you have to make sure you write the program properly, and it has to be stateless to make it fully recoverable. So not only are the generated applications more secure because we don't generate security vulnerabilities, they're more reliable because if a power line should be cut to your data center for whatever reason and that you lose power, you can immediately fail over to a different computer in that data center or in a different data center because the application was generated, and it was generated to be fully recoverable, a stateless, fully recoverable application. So the generators, we generate more secure, more scalable, stateless, recoverable applications, and we get a 10 times productivity gain to go along with it. Apex is the majority, again, the vast majority of new applications that are being started today are being written in a code generator, not a traditional programming language, because you're more productive and you're more secure. Okay, third pillar of using AI to make your systems more secure is user identity. This one, I think, is in some ways the most obvious, and I think everyone's going to be very excited about it. But it's really interesting. When you log into a computer, why do you type in a password? My name is Larry.Ellison@oracle.com. That's who I am in cyberspace. I'm Larry.Ellison@oracle.com. Now, why do you want me to type in a password? When I see Safra, she doesn't ask me for my password, and she recognizes me. Hi, Larry. What's wrong with a computer? Can't do that? Of course, a computer can do that. A computer can look at you. The camera can look at you. If you put your index finger on the return key, a camera can recognize you from your index fingerprint. It can recognize your face. It can recognize your voice. Why do you want a password? What is the purpose of this thing? People can't imitate my fingerprint. They can't imitate my face. They can't do any. That's very hard to do. So type in who you are, and we'll automatically authenticate you from a biometric database in the cloud. That simple. We recognize. We know who you are. We recognize you. You walk in, and people who are in the audience are probably saying, "Why do I have to type in Larry.Ellison@oracle.com? Why can't you just recognize me?" If we can do that too. Probably don't have to type that in either. But the idea that we use passwords is a ridiculous idea. It's obsolete. It's very dangerous. Passwords are collected. Now that we've made passwords very hard to remember, you know what people do? When your password is $, \, capital Z, small z, capital V, 1, 26, whatever, one of those things, everyone writes those down, and then they use the same password, the same exact password in every single logon, every e-commerce logon they have. They reuse their same password over and over again. And then those passwords get stolen and resold on the dark web, etc. Biometric logins are much easier to use and much faster and much more secure. It takes a couple of minutes to register yourself biometrically in a biometric database. You point your smartphone at your face for a couple of seconds. You put your fingerprint on the smartphone. You can record your voice if you want to, and we register it in a biometric database, the login database, in a couple of minutes. By the way, a year from now, you won't be able to log into Oracle. People who work at Oracle will not be able to log into the systems using passwords. They are just not secure. Therefore, that option is going to be gone inside of Oracle. Not everyone needs to do this. It's 100% voluntary, but it is much, much more secure. And there are lots of applications for biometric authentication. I know I've had to cancel credit cards, and other people steal my credit card number. People walk into stores, impersonate me, all of this stuff. They cancel my credit card. But identity theft is very common. Well, we can have biometrically authenticated credit cards. Same exact system. And people seem to like biometrically authenticated credit cards. Apple Pay is an example. Google Pay is an example. But we think rather than keeping the authentication in your smartphone, we have to have your smartphone with you all the time, though a lot of people carry it all the time. It's actually better and more secure and safer to keep it in a biometric database. And we can authenticate but there were about 22,000 credit card transactions per second in the world. Well, we can very easily authenticate them within sub-second response time. Authenticate people at a rate of 22,000 per second or much higher. That is not really a problem. We can do that. Well, what about, it's got to be up 7 days a week, 24 hours a day, can never go down. Well, that's how we built the Oracle database. It is because it runs on cluster hardware. We are fully fault tolerant. We don't ever have to go down. We live patch the database. Typically, we don't go down. So we can do this. We can make it so much easier. We can deliver absolutely fraud-proof credit cards that are biometrically authenticated. There are many other applications. Passport control. I mean, a lot of people, when you land at the airport and you're on the speed line going through, what do you think's happening? You're getting biometrically authenticated. Cameras looking at your picture and saying, okay, you are Larry Ellison, you just walk through. But what about schools? How do we make sure there's no one on campus that is not authorized to be there? We can use biometrics to make sure that there's no one entering this school building that shouldn't be entering this school building. There's no one driving into the parking lot who's not allowed to drive into the parking lot. We look at, you use license plate readers and facial recognition, pick up prescriptions, but also there are a variety of other things. There was massive fraud during COVID-19, people getting government entitlements for COVID-19. We can, well, because they pretended to be 30 different people and collected 30 times more than they were supposed to. We can stop all of that. That's actually fairly easy to stop with biometric authentication. It becomes very difficult to impersonate somebody else if you have proper user authentication. Okay, last one. The fourth pillar, which is network security. And for network security, a dear friend of mine by the name of Danny Hillis, same guy who invented thinking machines when he was an undergraduate at MIT, came to Oracle with this idea called Zipper, which is a next generation network security technology. And we worked with Danny, and we actually ended up buying a bunch of his company. And we took the ideas, Danny's ideas, and we implemented a new generation of network security. And it solves an incredibly important problem. Network security, if anyone in the audience here is in charge with securing the network either on premise or in a cloud, This is an astoundingly complicated problem. It's very complicated problem because when you configure a network, there are two competing goals. One is you want to make it very high performance, very reliable, lots of pathways, a lot of bandwidth. You got to make it very fast. Everyone wants their network to be fast and reliable. And then they say, oh, by the way, while you're making it fast and reliable, I also want you to make sure that no one's on the network moving data from point A to point B where that is not allowed. I'm going to give you this one set of tools for you to configure the network, but make sure two things are true. It's fast and it's secure. All right. When you do that, and let's say you're trying to improve the performance of your network, you add ports or add routes. If you're not careful, as you add ports and add routes and subnets and things like that, you could accidentally be creating these security vulnerabilities. It happens all the time. It's why it's so difficult to get someone to change their network configuration, because there are so many security audits required before you change your network configuration. And you get these unbelievably complicated pictures. I mean, you've got, over on the left, you've got the public internet. It's going through an internet gateway. It's going to a load balancer, a couple of load balancers, from load balancers to application servers, from application servers to database servers, from database servers through a cloud services gateway. Incredibly complicated picture. You try to configure the network with these separate zones, these safe areas called subnets. And it's very, very difficult to do. The slightest mistake, it can expose your data to the public internet. It can expose your data to hackers. So the solution to the problem is you really have to separate network security from network configuration. Network configuration, don't worry about two things, worry about one thing. Worry about making it fast and reliable. Then let's build an all-new system that's responsible for network security. And that all-new system will authorize certain paths through the network for certain users to use certain services, look at certain data, and only authorized paths are allowed. And no other paths will be allowed. So it's a brand new network security system that is separate from network configuration rather than blended with network configuration. And once again, we're going to use code generation. We're not going to have you write the code. We're going to have you simply specify the intent of how Zipper works. And to enforce Zipper, we have a code generator. To enforce Zipper, what we actually do is we have computers in our cloud that will look at every single packet that goes through the network and make sure it's an authorized journey from point A to point B. And that means we got these robots inspecting packets in our network. Billions of packets are being inspected every second. Simple example. So the code generator is, okay, how do you authorize a path? How do you authorize the data path? You simply say, I'm having trouble, okay, there we go. That this is saying, allow the accounting to connect to the database, the accounting database. It says, okay, you got a computer that is running the accounting applications, and it's allowed to talk to the accounting database. It might be the only application that's allowed to talk to the accounting database. And it's an easy to read English. Okay, so let's say we move or we move the database from one location to another. We even expose it to the public internet. Well, the only thing that can access that database, according to Zipper, is the accounting application. I don't care where it is. You can move it wherever you want to. You will not be exposed by changing the configuration. You will not be exposing your data. That's a very big deal. The system, robotic, will automatically adapt. You can change your configuration. You can add ports. You can do all sorts of things. And Zipper will automatically regenerate new robots to make sure that your data is still protected. And you suddenly get a much simpler network configuration. There are none of these subnets. You don't have to worry about security when you're configuring your network. You just worry about performance and reliability. And to protect this network, the entire thing, the entire, if you will, security program are those 4 lines sitting in front of you. And all of your security for your network is in one place. It's unified. It's all stored in one place, in one database, in the Zipper language. And the Zipper language then generates these robots. If configuration changes, it knows the configuration has changed. It updates those robots immediately before the network is then available to use. Okay, so we were able to implement Zipper in OCI because OCI has a very different network than any other cloud company. OCI has this thing we call it, it's a Gen 2 cloud with this thing called the Gen 2 network. I'm going to use a few acronyms. Our network architecture has different hardware and different software than any of the other clouds. We have a network called Rocky. That's an RDMA over converged Ethernet. Okay, what is it? Unbelievably fast version of Ethernet with this thing called RDMA, which allows one computer to look into the memory of another computer it's connected to without going through the operating system. It's like a very fast path that the computers can look at each other's memory if they're authorized to do that. So it's a super fast network, many times faster than typical networks. We also have network processors that virtual. So when we do that isolate our computers, our network, the Oracle Cloud Network is isolated from the public internet. We're not part of it's isolated from the internet, period. Because we do all of our network routing in our own computers, in our own network processors, and inside of our own hardware. We do that virtualization. We have that additional hardware in our computers, in our cloud, that does all of the network routing and does all of the network security. And then we have network controllers, if you will, that just manage the network processors. So when Danny came along with his idea for Zipper, it fit perfectly into Oracle's Gen 2 network architecture. So after a few discussions and we decided this is an ideal approach for the Oracle Cloud because we can do the packet inspection. We have all of these network processors that can run these packet inspecting robots and run them very fast, easily do billions per second. Not a problem because we have this smart network with these separate processors, separate memory that can do all of this packet inspection and make sure that only authorized routes, only routes that you authorize when in the Zipper language will propagate, to make sure no one can exfiltrate, no one can take credit card data or social security card data and move it from point A to point B because it's not authorized. So you combine biometric identity, getting rid of passwords, using biometrics, with this new generation of the zipper, this code generator, and these autonomous robots that do the packet inspection in the network. And you stop most serious cyber attacks. It's almost impossible for users to infiltrate the system if you're protecting yourself using biometric authentication. And it's pretty much impossible to move data out of the system across an unauthorized route. If it's not authorized explicitly by you, you have to explicitly say it's okay to move data from point A to point B. If you don't say that, the packet inspection, the packet robots, the zipper robots won't let the data move. And that's the vast majority of cyber attacks.